Hello everyone, how are you? Welcome back to this adventure, and let's continue what we were doing yesterday, which was, let me just check here something. That was the rebuilding of the control for the player spaceship. Okay. And let me just check one thing here. I changed something here in the stream. Now I can show some comments in the image if they are interesting to show. If I click on this button over here, I can read the comment. Hello. Once more. Okay. I wanted to put this on a button in my controller, but I didn't have time. So today let me check where we were. Spaceship 1, Spaceship 1. We did that rigid body controller, manager, the polar gravity docks there, the ship docks there. But if I'm not mistaken, yesterday we were not able of colliding, or when we collide the velocity was 0. So let's try to find where the information is lost to see if we can solve that problem. This belongs to the rigid body manager. We do the calculations, we apply the calculations result, and then we get the linear velocity, the rotation degrees, and the angular velocity. Maybe that thing with the current velocity and the old velocity, I will do it in this script. Maybe I will do it here. So linear velocity is whatever it's happening in real time, and public vector 2 old linear velocity is what happened in the previous frame, meaning copy paste old velocity equals to rigid body to the linear velocity, just linear velocity. Sorry. The problem is this is all happening in the same frame. And I believe that I will still have the same problem. Let's make the ship look at that old velocity instead of the internal one. Where is the we get, no, we don't get anything here. So this old ship velocity will be equal to rigid body manager dot old linear velocity length. Yes. What did I have here? Undo. Ship velocity. Okay. Let's get, this is the ship velocity, and then we get the old at this point. After we do this, whatever. This is not important. This is just numbers for the interface. So this does not affect anything. This will not work, but yeah, rigid body. Old ship velocity, old ship velocity should be as only a float. Yes. So let's go rigid body manager old ship velocity dot length I believe this is not happening in the correct frame, in the correct position. Let's try to collide and see what happens. What is happening? I need to go to Godot, play.
Prepare for main engine burn to decelerate as you approach the station.
Yeah. So let's look at the numbers. Impact 0. So we still have the same problem. Maybe we need to set up the velocity. Rigid body manager. So we set up everything and we say here the old velocity equals to linear velocity, because in the next frame, so here we need to calculate the velocity here, or calculate the velocity difference here. This calculation needs to happen after we have the new velocity and before we change the old velocity. So this needs to happen here. The old velocity will be updated after the calculation. We set up everything. The linear velocity is already equals to whatever is there because we are calculating it. So at this point we need to do the comparison before we change the old velocity. So this is the place. Instead of having here old velocity, okay, the linear velocity is now, old is previous. we can have here a public float with velocity delta maybe, and this velocity delta will be equal to linear velocity minus the other minus all the linear velocity and everything length. Everything as a number, but everything needs to be positive because we don't want to deal with negative numbers. So let's go math function.abs and let's get to the absolute value of this length. So velocity delta will be the difference, and this needs to be now what we have to detect to avoid that starting at full speed and then the old velocity be 0, so the difference is a lot, and because it's a lot will crush the spaceship. We need to make sure that if this is the first frame, the old velocity equals the linear velocity before this. So this is always 0. So we can have a boolean is first frame. Is first frame equals true. So when it starts, it's first frame. Let's make sure this is true. Even if we restart, copy ready. Even if we restart, yeah, okay. This should make sure that it starts as true every time. And now let's do before this we will say if is first frame we do this thing and we say for is first frame equals false, so is no longer first frame. Oh, come on. Is first frame equals false. So this will only happen in the first frame. So if we start with a lot of velocity, this will have the number 0 there. So the spaceship will not explode in the first frame if we start already moving. So what we need to do now is to get this velocity delta directly on the other script. I believe it's a public. Yes, it is. So spaceship, we don't need to calculate this anymore. Ship velocity, we don't need to calculate this anymore. Undo. So we get input, we process the movement, we do everything. At the end, we get that number from the other script. So rigid body manager dot velocity delta, and we have here the I will use the same name in both locations. Ship velocity. Undo. Control F, find, replace, paste all. Velocity delta equals to whatever delta is calculated on the rigid body manager, and we do the math with this new number. Velocity delta is happening also down here. Impact velocity equals to, we don't need to do this anymore. We just need to use the velocity delta directly. Velocity delta, if velocity delta is higher than whatever it needs to be to explode. Structural integrity. I don't know. Oh yeah, this is to play the sounds. It could make an impact sound before explode. So if it impacts without being strong enough. So this is cannot be inside that one, and I believe we should have something working properly. Let's see. If we start and the spaceship breaks immediately, maybe not.
Prepare for main engine burn to decelerate as you approach the station. Use thrusters to align with dock 2.
0, 0. Why? Maybe I'm using the wrong thing. Oh, come on. Maybe I'm using the wrong thing to calculate the velocity. Linear velocity. Let's look at the rigid body to see. What we have here. Velocity. This is linear velocity. The body linear velocity in pixels per second can be used sporadically, but don't set this every frame, because physics may run into. I'm not setting, I'm just reading it, so maybe this is not the thing. Constant force, no. Angular velocity, also no. Yeah, it should be the linear velocity. Let's play the game, not in full screen this time, and look at the linear velocity of the spaceship, because this 0 doesn't make sense. The number 0 do not make sense. Does not make sense. Continue, let's go with one that... It could be this one. Before going there, I will mute the sound, because we don't need the sound to test this. So let's look at the, let's start the level first. Level 4, play. Let me stop the spaceship so it doesn't go out of the screen. So now let's go on remote, a station approach level, canvas layer, spaceship, and we should see here linear velocity. We have numbers, and if I go faster, the numbers change. So yeah, this is the numbers I want. This is the numbers I want. So I will print here linear velocity, and then set the velocity to old velocity. Let's print the velocity. Print the linear velocity. I believe this is a vector. Yes, it is. So let's do the length thing. So we actually see just one number in the print. And let's do the same. Copy paste. Let's actually see first old linear velocity. And the new. So this old comes from the previous frame, because old will be set here, so the next frame will get the old from the last frame. And linear eventually is the one being calculated on this frame. Let's play a little bit. Let's print some numbers and see what happens. So if I'm maintaining speed, I should see 0. That's normal, because I'm not accelerating, I'm not deaccelerating, so subtracting one to another should get me the number 0. Maybe I need to transform the vector into a float before do the math. So if I'm not accelerating, I should have the same number in both of them. But if I start to accelerate, let's pause the game. Whoa, accelerating all the time, pause. Old is the same as the new. Well, it's changing. Old, new, 89. So yeah, it's going up. It didn't change in the last 3 frames because I pressed the pause button probably. Yeah, but old 605, new 609, so they are different. Okay, so the math is working. Let's see this impact. We should see a very abrupt, yeah, hold new, and the difference is like 385 minus 78, 300 of difference. So maybe I need to set up a number around this. Okay, let's stop the game. 300. Where do I break the machine? I should have here something. This needs to be organized. Broken structural integrity 500. What do I do to this number? I subtract the number, I guess. Let's go on the ship. Structural integrity. If the velocity is higher than at the moment of impact, it's strange because when I impact, I believe I will not use the impact signal to detect the impact. I will just read the number continuously, and if it goes, because I believe that this impact method that is being called when the body enters the other body, when they impact, it's giving me 0 because maybe it has a frame of 1 frame of delay, so they are already stationary. I don't know. I don't like this way of. Why is this printing 0 when clearly we have difference in old and new? Let's print the delta. gd.print delta. Velocity delta. And this is called delta something or something delta. Velocity delta. Okay. So let's print this velocity delta and let's look at the console again, just to make sure the delta is not 0. Because it's very strange. Why do we have 0 on impact if the numbers aren't different? So 0, because I'm not accelerating, I will start to deaccelerate. Yeah, delta is 9 point whatever. Accelerating, delta is 4. Accelerating the other direction, delta is 4. Rotating, I should have something here, but let's go. Yeah, delta 50. Delta around 50 on impact. I believe I saw 800. So we have a 400 here and 800 here. This is the strongest deacceleration. So this should break the ship. And on impact, we are getting 0. This script was printing 0. Impact. Where is this impact? It didn't print. Copy. Can I find something here? Yeah, impact was 9. So this is not correct. This is not correct. What I believe is happening is that when the impact happens, the speed is greater, but the signal is transmitted on another frame where the impact is no longer at the highest point. So when this is called, this velocity delta is already a low number, and that's why it does nothing. So I will check this impact manually. So this rigid body, I don't care about you because I will not use the signal anymore. Where is the connection to the signal? It's here. I don't care about this. Save. And I will check the impact every frame. Check impact. This will be called every frame. So where is the process? We get input, we process the movement, we process the visuals, we check dead zones. This is not done. And at the end of the frame, we make sure we are not above the limits of speed. Okay, let's play and see what happens. So many hellos. Yeah, I was testing something. Do you want to know what I was testing? I can show you a message now in the video. See? Oh, lol. Maybe not. I don't know why this is not showing point. Yeah. No, it's actually showing the. Let me see. Let me try again. Aha. Write another one. I will write another one. Wait. Aha. See? It's showing the message. The delay is the delay I have. There's nothing. Yeah, I have like 2 or 3 seconds of delay. So if I feel that is important to show your message, I will show it. It's not on every time because, you know, it could go wrong. Anyway, play settings. Let's play. Let's see if the spaceship explodes or not. It didn't explode, at least. Maybe it's not fast enough. Let me restart. Point there and go even faster. Aha! So it's actually breaking again. Maybe the number is too high. But at this point we are actually breaking again. And let me test the other the planet level, because I believe that I will start without breaking the spaceship in the beginning. Yes, I'm alive. Let's see what happens if I go against the planet. Let's fall on purpose. Yes, I'm broken. Nice. Very nice. Really, really, really good. So the objective of this level is to fall, not fall, but get into the orbit, so without falling. The planet needs to go slower because I cannot enter the orbit at this speed. Let's go on the step. Rogue planet. Planet. Maybe 10,000 instead of 3. 10,000 instead of 30,000. Up 6,000. Maybe 3. Let's play again. Play, last level play. Okay. Yeah, this is more controllable. I will fall. Okay, I'm in orbit. Maybe it's too elliptical, but let's solve the problem right now. Deaccelerate here. Circle. I need to accelerate this side so I get a circle. Okay, I'm in orbit, so I can finish the level, which is go around the planet 10 times. This mission will be something like we detect a new planet, a rogue planet that will pass through the solar system. So let's send all the ships we have to investigate the planet, because it will enter the solar system and it goes away. That could happen. We don't know. Maybe the planet that is coming to us comes from the other side of the sun and we cannot see it until it's too late. Anyway, that's possible to happen. It happened like 2 years ago with a comet. Or last year, I don't remember. So why not with a planet? The planet is going too fast. Too fast. No, it's not going too fast. We need to control the ship to keep it in low orbit. Yeah, we need to control the ship to keep it in low orbit. So let's start to deaccelerate here. I will fall almost. I need to accelerate here or else I will fall on the other side. Oh, okay, deaccelerate the low orbit. Keep the speed in the high orbit. Oh, no. Deaccelerate. Maybe I will not do 10 laps around the planet. I need to go lower. Because there will be another part of this mission which is, okay, go 10 times around the planet, because we need to photograph the planet. So we will actually need to maintain the attitude, which is where we are pointing, so we can have the pictures of the planet. So we cannot just go 10 times like this, you know. I'm just randomly rotating around. Well, this will not be a good solution for this. We need to kind of go always pointing the same direction. So maybe not 10 laps, yeah, but whatever. This is a chill game about space, so. And maybe at the end we can have something like, okay, now return to Earth before you get out of the solar system with a planet. So maybe at some point we could have something like enter the route, the orbit, like go around 3 times to photograph with a camera pointing at it. So that small window pointing at the planet. And after 3, okay, I'm dead. I'm dead. Those parts didn't fall into the planet because they don't have the polar gravity script. So maybe I will do that and see if the debris fall into the planet. Where is the spaceship? Is here. The broken spaceship is here. Can I open this scene? Yes, I can. So each one of these rigid bodies should have also the polar gravity. But the polar gravity does not the polar gravity does not control the rigid body anymore. So they will also need to have, let me look at yeah, it could be the planet, the rigid body manager and the polar gravity. Copy, broken ship. Let's do just one and see what happens. Paste. And what I do when I instantiate the broken ship, the broken ship so I have a list of parts, and for each rigid body, if the child is a rigid body, child linear velocity equals to linear velocity. This linear velocity is set body, comes from outside. Yeah, it should work. Maybe not, but let's see. Undo, maybe not. It should work. I will solve this debugger here with many errors later. Let's see if the parts, at least that part over there, that is the first one, falls into the planet on collision instead of being projected outside. Let's go full. Godot and Unity also, and maybe Unreal, I don't know. They have like no, but maybe condition mass lower than 0. Maybe they don't have the correct mass, or 1 kilo is not enough to fall, probably. The ship has how much object mass? 100, and kind of behaves normally. So let's do 100. Let's do 10 for each part, or 20. I don't know. We can fake it a little bit. Let's do 80. So they are a little bit lighter, but not exactly. Rigid body manager doesn't have anything to configure, so let's put that. Oh, and I need to do something else. Freeze mode. I need to enable something. Maybe not. What I need to enable is for the messages when they collide. And I just want physical reactions here, so planet. Let's fall directly into it. I need to disable the time. Let's put the end of the level. Where is the planet? Rook planet. How much time do I need to wait for the next level? Delay to achievements. 3 seconds. Maybe here. Let's go 30 seconds. Well, I can I can do this on another place. I have here the test scene. I can do it here. I will lock these planets. Freeze. Will not fall. So are they floating? I guess the number 1 is this one over here. So polar gravity line 30 is giving me problems. Let's look at the polar gravity line 30, parent rigid body mass, and the parent is polar gravity should be a child of the rigid body. Where is the broken ship? Yeah, polar gravity is a child of a rigid body. Everything looks nice. So next problem. Cannot access a disposed object. Which object? Polar gravity. Ship 1 goes away, but something is trying to access the ship 1 script. Oh, I know what's happening. So planet has a polar gravity, and this polar gravity of the planet has a list of rigid bodies. When I make the spaceship explode, that rigid body no longer exists. And because it does not exist, when it's trying to calculating the attraction, it's trying to calculate the attraction with something that no longer exists, so it throws the error. This error here. Cannot access a disposed object, of course not. And this is happening this many times because each planet is every frame trying to calculate the attraction of of the spaceship. So what I need to do this is why the event system is great, and it's much better than the signals. I can just transmit an event saying I will disappear when so the ship transmits that event. Everyone that needs to listen to the event listens to the event, so every polar gravity will listen to that event, and when the ship goes away, it transmits the number of the rigid body, so that number will be removed from the other lists. That's the thing. Or second solution to that is to have some kind of script above everything with a list, and every element communicates directly to that list. I guess it's easier. But that means also, or that also means that let me look how the polar gravity sets up the list where targets. These targets are set up where? In the ready function. So this is the problem. When the game starts is where we have the list being made, the list of objects that will attract each other. So if something changed during the game, one of the objects goes away or a new object appears, for example the ship goes away and the debris appears, they will not interact with each other because this list is not being updated. So what we need to do is every time a rigid body enters the scene, the targets will add that new rigid body, and every time a rigid body goes away, we will do remove. I guess the list has that option. Targets dot remove. Yeah, remove, and inside remove we say the rigid body that needs to disappear from the list. Okay, nice. So this is possible and easy to do. The thing is, how do I access the targets, or when do I update the list? Every frame? Do I update the list every frame? Well, that will be expensive. Imagine that we have an asteroid field with 200 objects. If I need to check 200 objects every frame, maybe it will be expensive. So the targets could be on a script above everything, and all these polar gravities, instead of using an internal targets list, they use that above targets list. So if I change the targets list at the top, all of them are updated. Yeah, that's the way. Except for this. Because if the rigid body that is being calculated is the same, well, I will attract full force into me, you know? So myself cannot be inside my polar gravity, just the others. So maybe I have a list with all of them, and when I calculate here, when I calculate the direction, I do the if statement. If the rigid body in target is equal to rigid body, ignore. Yeah. So let's comment. If target RB is equal to this RB, ignore. We need to do this here. This will no longer happen here. So this goes away. And we need that script that is above everything. Let's go to Godot. Let's create that script. Script. Well, let's call this polar gravity bodies. This will just have the list. These polar gravity bodies will not be in any of these objects. That will be directly in the autoload. So let's go scripts, list. Polar gravity, I forgot the name. Polar gravity bodies. Okay, open. So polar gravity of bodies will be there. Let's open this script and edit it. Polar gravity bodies. And we can do something. Maybe I can turn this script into a singleton. So, oh, maybe not. I'm not sure. Maybe I will not do a singleton, and I will not. Let's go polar gravity. So I need to have a list of things. So let's start creating the list. So this goes inside the other script. Polar gravity bodies is a list, has a list. We need this library to use lists. So we have the targets. But we are not going to detect them from here as we did in the other one. So in the script we have the list, and then in the start or in the ready function we get all of them. But we are not going to do this anymore. What we are going to do is to have a method to add rigid bodies there and another to remove rigid bodies from there. So public void add target, and this will receive a rigid body 2D called target to add. And here we just say targets.add target to add. Kind of simple. So every polar gravity will call this function and it will report itself. So if something enters the game in the middle of the level, it will be added to the list, which is nice. Same thing to remove them. When something explodes and disappears, it needs to be removed from remove target to remove, and instead of add we say remove. We don't need any of these default methods, and that's it. So now we have a target rigid body that is above everything. Yeah, a list of rigid bodies. So now we just need to reference these polar gravity bodies and talk to it using these two methods. So the polar gravity, instead of doing this, it's going to report there. But to access the polar gravity bodies, we need to have a reference to that, and I don't remember. Let me check. I need to check something. I never learned this. Oh, I can show you what I'm doing. So I have here this website, work in progress website, very work in progress. Anyway, everything I need to do something that I don't remember, I write it here. So that's it. Access a script in autoload is what I want to do. So I need to have a reference to it, and in the ready function call it. Okay. So polar gravity needs to have a reference to the other polar gravity bodies. That will be called polar gravity bodies. In the ready function, we get it. Polar gravity bodies equals to polar gravity bodies in polar gravity bodies. That's it. So now that we have a reference to that above script, we just need to call it polar gravity bodies dot add target, and the target will be the rigid body, parent rigid body. That's it. We should have a list of here. We should have a list full of rigid bodies. No matter how many we have, they will be added there. Now we need to clear. Oh, the ship will do the same. Yeah, the ship is a polar gravity. So if I do this in the polar gravity, I'm actually affecting all of the I'm affecting all of the physical objects, because the ship also has a polar gravity, the planet has a polar gravity. It's here. Eventually the broken ship, the parts of the broken ship have polar gravities, so all of them goes there automatically as they are instantiated. Now we need to remove them when the thing goes away. So ship, when the ship is being destroyed, or when the polar gravity is being removed, because when I destroy the ship, this goes away. When this is being removed, we need to do the opposite of this. And there's a function of going away that I don't remember. I guess it's exit 3. I believe it's something like that. Exit. I need to go public override exit 3. So this will be called when the object is removed. So here I will do the opposite of this, which is remove body. Instead of remove target, instead of add target, remove target, save. I didn't save. Godot, play, and let's see if we still have these 2000 or whatever errors when the thing gets broken. Let's go to the test scene directly. Oh, yeah, no, sorry. I need to do another thing. I'm not calculating using the above list, so yeah. To calculate the, where is the calculation of the physics here? For each target in targets, well, this targets is the internal targets. It needs to be the targets in the polar gravity. So we just need to say here polar gravity bodies dot targets. Targets is not a public list, that's why I cannot access it. Public list. Yep. So now the, oh, and yes, this is okay. And now I need to ignore the self rigid body. So if the target that comes from the list, it's not equal to what? Parent rigid body. If it's not the rigid body, the parent rigid body, we do the calculation. If it is the parent, it will ignore. So this will not happen. So this means that it only calculates the attraction of all of the other objects except the self object. So now this should be functioning correctly. Let's see. Come on, break, have an accident. Okay, yeah, that thing, the only one that has the polar gravity, it fell into the planet. And we have errors. We have one bug. Yeah, this is not a problem, I guess. So now let's add the polar gravity broken ship, this rigid body manager and polar gravity copy to all of the debris. Paste, 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 and finally paste. Why do I have an audio stream player inside of this one? Maybe this audio stream player shouldn't be here. Okay. This is probably to play the sound of the broken ship. Okay, so all the debris have the polar gravity. Let's test the thing. What? What's happened? What's happening? I will remove one of the planets. That will just make the thing fall. Let's move the ship over here. What? What's happening? Maybe I had something. all of them needs to be a little bit heavier. Let's go 80 again. Impact is there. Broken ship. Oh yeah, that broken ship, whatever, this audio autoplays, so it's just a sound. It's not very important. This is what? Okay, undo. Okay. Somehow it was working with just one, but not working with all of them. Very strange. Ship, ship, broken ship is here. Let's play the scene and see. Not this. Go down. Let's look at the remote window to see what's happening inside the scene. So let's play this scene over here. Can I pause it? Okay. Let's look at what we have. I cannot do it. So we have the spaceship, the planet and the camera. Okay. What? The thing disappeared without... Oh, I'm looking at the local. Come on, let's restart. Remote. Pause. So we have the polar gravity bodies is here. The node to the is the level. Ship 1 is here. Yeah, the ship was removed, but somehow the broken ship was not instantiated. Strange. Let me revert the thing. So undo here. Let's see what happens. Can I do an undo? Yes, I can. So this was working. Only one rigid body element. This was working this level. Oh no, we have something here happening. Wait. Okay, we have something. Not... maybe we cannot access the polar gravity bodies. Perhaps you paste something in the wrong place. Oh, this window does not update. Yeah, ignore the message. Yeah, Nuno said, perhaps you paste something in the wrong place. Maybe. Maybe I did. But when I tested... Okay. something's wrong. Let's see, I undo the thing and then probably I destroyed something. I know. So let's see what's the problem. I cannot access this. Target is different from parent rigid body. This was working. Polar gravity bodies. We have enter tree. Ready happens when we start. We get the thing. It should be there. Root polar gravity bodies is the same name. So, or maybe I need to specify. Oh, come on. Probably. Let me look. No, I don't need to specify the extension of the file. I don't need to specify the extension, so it's actually finding it, or else the error will not be there. The error would be here directly because this didn't exist. So yeah, we have the parent rigid body reference set up. This is actually searching for it at root. So no matter how deep it's inside a tree, it will find starting from root. Project settings, auto load. Maybe I undo too much. It's not here anymore. I undo too much. Polar gravity bodies, open, add. Okay. Close F6. When I undo the thing, I undo until the removal of the thing. Okay. So, nice. Let's do copy, paste. Let's play again. So now 2 elements of the broken ship have the polar gravity. The spaceship stays there, and now I have 2 errors. Okay. Condition P mass lower than 0 is true. Polar gravity 36. So this error happens on polar gravity 36. Object mass comes from where? Oh, it doesn't have anything. It doesn't exist. So I'm trying to set up the rigid body mass based on a number that does not exist. And why? Because in the spaceship, or in the spaceship, the ship 1 sends that number. Yeah, sends the number there. But the debris don't have anything to send the number. So maybe I can just give it some kind of default value, or I make this export public, save. So if I change it, I change it. If I don't change it, I can set up the thing in the inspector. Did I build it? Okay, so this body polar gravity will be 80. Okay, and this body, I didn't press enter. Yes, okay. Polar gravity will be 80. And now I don't have that problem anymore. Copy, paste. Let's play like this. Or I don't have any errors, or I have 3 errors. But I believe I will not have anyone. Wrong play. Because the default value is not 0 anymore. Yeah, no errors at this point. And no errors at this point. And the 3 objects that have the polar gravity, they stay attached to the planet. The others don't. Okay, copy. Paste. 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 Just one missing, as I was predicting. And now I will put here the last one. Paste. And the ship will disappear. It would be funny. Anyway, I don't understand why the ship was disappearing before. It doesn't make any sense. So let's play the level planet insertion. And let's collide by accident, but in a more interesting orbit. Let's go. Oh no, I'm going to collide. Oh, it immediately falls down. I would like to have like that, the thing that we had before. Maybe I'm adding the velocity in the wrong place. Because when they collide, when the ship collides, where is the broken ship? Is here. When the ship collides, we instantiate the broken ship. We put the broken ship in the same position with the same rotation, and we get the linear velocity of the spaceship, and we set up the broken ship with the same, all of the bodies with the same velocity, so they should keep the same direction. But maybe they are too heavy and they fall immediately, or maybe I need to do this linear velocity in the polar gravity. Let's make them lighter and see how they behave. Broken ship, all the polar gravity. Variables goes like 1 kilo. Let's see if this behaves better. Oh, I have here some 2 problems. Okay, this is the menu problem. This is not a problem for today. Continue, planet, rogue, planet. Let's fall again into the planet. No, even with 1 kilo they lose the directional velocity. Yeah, it's actually, it's like a magnet, Nuno says. Yeah, it's like a magnet, but the problem is not that. Because it should be like a magnet. It should attract, but it should keep at least a little bit of the direction, and then it starts to be attracted. And yeah, so maybe let me see. Polar gravity calculates the attraction immediately at frame 1 because it has access to all of the rigid bodies. Can I delay this for like 2 or 3 frames? I will do something interesting just to make sure. I will bypass the entire attraction. Oh no, I cannot do this. The polar gravity works on all of the elements. And okay, save. So I need to make sure that the linear velocity is actually updated inside this script. Let me clean this script because it has a lot of garbage here. So enter 3, we get the rigid body manager. Nice. Exit 3, we remove this object from the list of objects. Okay. On ready. Polar gravity bodies. This could be, yeah, on ready. On ready we get the script that has the list of every object. And we don't need this. A parent rigid body get parent, so we actually know who we are. And rigid body mass equals to whatever number I put there. In this case is 1. I will make it 0.01 by default, because mass cannot be 0. If the parent rigid body is null, we have an error. Okay, I don't need this, but yeah. Convert linear start velocity from local to global space. This is because what? Why do I need this here? Global velocity. Oh, I'm setting up the velocity directly. Parent rigid body. No, I cannot do this. It needs to be through the rigid body manager, not from here. This thing here. This linear velocity needs to be set up in the rigid body manager. Yeah. Yes. So let's do another public void set starting velocity, and we will send here vector2 linear velocity. Okay. We need to put this copy. We need to have a public, well, not a public. We need to have, where is the velocity? Old, new, whatever. Let's create here a vector2 linear velocity to set variable. Copy. And we will calculate everything as we did before. And then we are going to say if linear velocity to set is different from 0, come on, this is a vector. Cannot do this. Can I have a length that is 0, but it actually has some numbers? No. If it's 0, it's because I don't have any direction. Okay. So if the linear velocity to set is different from 0, we will sum this again. Final force plus equal linear velocity to set and we put that at 0. Equals to a new vector2. Why I'm doing this way? Because I want to make sure that the linear velocity to set is being applied to the rigid body already summed to the ship force and to the polar gravity force, and before the calculation of the old speed and the new speed. So I can only have one access to the rigid body per frame, just one. So everything that needs to go to the rigid body needs to be calculated before this line, and actually needs to be inside the force, the final force variable. So this direct access I had here cannot happen. We need to talk to the rigid body manager and call for this. And here we will say linear velocity to set equals to whatever comes from outside, equals to linear velocity. Okay. So set whatever, copy, save. So here, instead of talking directly to the rigid body, we will say set velocity, and we can actually put this number here, So this will not happen when this happens. This will happen. Rigid body manager dot this. So this will happen when I want it to happen, not because this is in the ready function, but this could happen inside inside the loop in the middle of the game. For example, imagine an explosion that needs to add force into one direction. I can call this and add the force there. It will happen in one frame, so it's like the add impulse, but it's not actually an impulse. But the thing is, I'm making sure it happens before the calculation of the delta. I can delete this. Save. So the starting velocity will happen inside the rigid body, meaning that when the thing explodes and we say move there, maybe it will keep the values. So this global velocity is the parent rigid body get transformed, blah blah blah. So this is to get to the direction, and the start local velocity is the variable that we set up from the ship when we collide. So yeah, probably this will work. I don't need to create a variable to calculate this, because I can put this inside there directly. But for now, we keep it this way, because let's start the game again. Where is Godot? Oh, come on. Here. F5. Play level. I can also delete. Okay, they are attracting each other, but now the speeds are very different, so I need to probably readjust the numbers, and the planet is no longer moving. Yes, very nice. Now it works as I was expecting. It doesn't fall immediately. Let's go faster to see if we can actually go into orbit. Let's go faster. Bam. Yes, it's actually working. Very nice. Very nice. The game is still ending in 3 seconds. So let's put again here 3 seconds. So where is the delay to end the level? I don't remember. Level manager? No, level manager is not this. Mission briefings? No. Level progression. I don't remember where I put the thing that ends the game. Level objectives. Maybe it's here. but I don't have a public variable. Check connection. This is for, no, this is not it, because I don't want the level to change in 3 seconds. Yeah, it's here. I have an hard code number. So let's end game area. Let's put here a variable. Export public float delay to end on lose equals 3 by default. Delay. Copy. And let's go paste. Save. So now I can have more time. "30 seconds. Okay, save. Let's see why the planet is no longer moving. Maybe this weight and this acceleration is not enough. Let's remove some zeros here. Oh no, I cannot, because it will not attract anything. Let's go higher here. Speed 19,000, and this could be 10,000. Let's see if the planet moves again. Start local velocity. The start local velocity will talk to the polar gravity, if I'm not mistaken. Oh, it's not, because the spaceship, now it's falling, but in the beginning was moving. So let's see, what did we change? Start local velocity. Is being set on the polar gravity start local velocity. Polar gravity start local velocity is being yeah, this is actually not working. Set starting velocity. Let me check if that thing is actually working. Where if it's first frame, let's print here this linear velocity. No, it's not this. It's here. Blah blah blah. Let's Godot print. Let's print what? Linear velocity to set. Copy paste. Set linear velocity. I need to remove this impact. This impact comes from where? I don't remember. I believe it's in the rigid body manager. No. Polar gravity. No. 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 Maybe ship. Yeah, it's here. Let's comment this one. And let's play the game, see what happens. Doesn't print anything. Nice. That's actually good. That means that the number is not reaching the number is not reaching this variable. Linear velocity to set doesn't need to be public because we are not accessing it directly. We are calling this let's print here. Save. If it prints now, means that the scripts are communicating with each other. Well, they are not communicating with each other. So set starting velocity comes from the rigid body. This happens in the ready function. We already have the parent rigid body connection. No, the rigid body manager is already, yeah, it's already set up, so it should be there. So why this is not talking to the other one? Polar gravity. I don't understand. So everything talks to the correctly to the rigid body manager. Or maybe not. Polar gravity, yes, it is, because it's being attracted, so this is actually being correctly referenced, or else the attraction would not work. So set starting velocity. Okay, if it's not correct, we have an error, and this is expecting a vector 2. This is a vector 2. Yes, it is. Let's print this this thing here, because maybe this is 0, but I don't believe it's 0. Godot print let's say obvious sent. So we should have one number, one vector actually, when we start level 6. Two numbers. What is happening? So this is not happening. Why? Something is very wrong here. Polar gravity. I'm not seeing what's wrong. Do you see what's wrong? Because ship has the polar gravity. I should have a number in the beginning. I believe all of the other levels are not working also. For example, this one here, the spaceship will never enter the level because it's stopped above. Yep. If I go down, yep, I can enter the level manually, but not automatically. I don't know why this ready is not happening. Because this print should happen no matter what is inside the ready. Should be print LV sent 0 if this was not being properly calculated. So the polar gravity I don't know. I don't know what's happening. Let's do, where is the ship? Polar gravity has the script there. Yes. This doesn't make any sense. This does not make any sense. The planet still has polar gravity, so the planet should also print something. 0, I don't know. Not an error, not anything. At least an error, come on. Give me something. Oh, wait. Is writing something, but I'm not seeing it. Toggle visibility of standard output messages, yes. Oh, come on. I'm searching for the word impact, that's why I'm not seeing anything. Blech. Very smart. Play. Or maybe not. Filter messages. No, I'm not filtering messages, but this is off. Okay. LV sent. It's here. Set LV. It's here. And we have the other one from the planet, the other one from the spaceship. So the numbers are reaching the destiny. Set LV. Set LV is here. So let's see if it's actually setting up the LV. If linear velocity to set is more than 0, is different than 0. Save, return, play. If it's different from 0, we set up the thing. Let's see if we have the print now. Oh, we don't have the print. Okay, so this is not working. This is the thing that is not working, because this print is not happening. And this is inside physics process, so this should happen as soon as this number exists. Can we print? Paste dot length. So let's see how long is the vector. It should be big, because 3000 is big. Play. Stop. Set LV 3000 something, so it's higher than 0. It's different from 0. But strangely, I have, okay, yeah, I have the vector there because I have the print twice. Okay. No, it was reaching here, the length. Final force equals to whatever final force it is, plus the linear velocities to set. So we update the final force. Let's make sure we update the final force. Let's print before and after. I'm actually testing something that is very stupid to test. Because come on. They need to be different. Before 0, no movement. After, a lot of movement. Yeah, of course. So why linear velocity is not that? If the number is there. So final force, apply force. Maybe I need to set up the linear velocity directly in this case, instead of apply force. But I want to apply force. Let's do the numbers bigger. Extremely bigger. So this times 1000. Save. Maybe that's the problem. Linear velocity, it's not a force. And maybe that's the problem. The number is too low, even if it's extremely big. Let's go play. Yep. The spaceship went. And the planet is actually moving as I want. Okay. Let's keep this way. Because force is not velocity. We don't need the prints anymore. And we just need to set up again the speeds of the spaceship in all levels. So in this case, rogue planet, the ship is too fast. The planet is kind of okay, but the ship is too fast. Where is the ship starting velocity? Yeah, let's remove like 900 and see if it's actually better. I didn't press enter, so the number didn't enter. Play, continue, go, rogue. Okay, 900 is also too small. Let's go 9000. Save. $9,000 is too small, and it starts broken already. So we are still with the same problem as in the beginning. Let's go 20,000. Oh no, wait. If it starts broken, probably the number. Let's check the script again, because it should calculate the speed if it's the delta after all of this. Calculate the velocity difference here, and if it's the first frame, we set the old linear velocity to the new linear velocity, so it shouldn't break in the first frame. Even if the speed is extreme. So I'm not sure where the algorithm is not functioning correctly, because we apply the force linear velocity to set. If it's not 0, we will add that number to the final force, and the final force will be applied. So technically it has speed. So, or it has a velocity set up already. Die R3 is starting on TV. Yeah, I will not see Die R3 again. Come on. Like, I already saw that movie like 20 times or more. Yeah, at least 20 times. Come on. It's from the 19th. So, how many years it was? Let's print linear velocity. Let's print linear velocity to see if we actually have a velocity already set up at this point. I believe we have linear velocity. It should be above 0. Save. I believe that the problem is not there. Continue. Okay. I didn't change anything. I just did a print. I don't even know where is the number. Should be a single number. I don't understand. I don't know what happens. I'm not understanding. I didn't change anything. I just had a print here. What? This is the Schrödinger's cat or whatever? If I'm looking at the number behaves, but if I'm not looking at the number, it doesn't behave. The number could be 0 or not, but if I'm looking, it's not. You know? Come on. Why is not breaking? No, it's okay. I don't know. I don't know what's happening. Anyway, ship speed should be slower. It's too fast. Let's go 8,000, maybe less. Yeah. Let's try 8,000 and see what happens. Save, play. Play. Okay, the ship is not broken, I guess. The ship is broken. I don't understand. Maybe it was broken all along. It's alive and it's dead at the same time. Let's see this level, if the thing starts broken. Yes, it starts broken and super fast. Station approach needs to be extremely slow compared to the other one. So let's go like 100. Save, play. Play. Level 4, play. 100 is too slow. But it's not broken. So the problem is at this point. Here is the problem. Let's print the number again to see what happens. Or maybe this is not happening, because I don't remember. Let's say like ship is broken, and we have a lot of them. We should have only 1 or 2, because we have, or no, yes, we have 2. The planet 0, 0. 0, 0. Linear velocity 0. Well, here's the problem. We don't have velocity yet at this point. So alt velocity will be set at 0. Next frame, linear velocity will kick in, and this is 0. So I don't understand why this is not working now, because before we add this, okay, I know what's happening. Before we add this, we were adding linear velocity directly to the rigid body in another ready, and this ready was happening first. So when this one works, not this one. Yeah, we were doing this. We were doing the linear velocity directly into the global starting velocity, and we were changing the linear velocity directly. So we were putting like hard numbers into pixels per second, not a force. Because pixels per second is independent from the force. You know, if the thing weighs 1 kilo or 1000 tons, 10 pixels per second is 10 pixels per second. But if the force is like 200 kilos and the thing weighs 1 kilo, it will be a lot of force. If the thing weighs a planet, it will be nothing. So force is different from linear velocity, that's okay. But somehow, because linear velocity already exists here, when we reach the point where we test the linear velocity, the thing has value, and that's why this works. But when we add a force, the force will be applied at the end of the frame, if I'm not mistaken, meaning that at this point, if we are working only with forces, apply force, this will be 0 until the next frame. So can we... No, I don't want to do it. I don't want to change the velocity directly. I don't like it. I want to transform this linear velocity into a force here. Linear velocity to set, or let's change this name again because I don't like this name. Find, replace with linear with a force to set. Replace all. This is better. Save. Same thing in this side. It's time. It's time to go to sleep. You can go. I will allow it. Oh, ice cream. Okay. Nuno says ice cream, not time to sleep. So, yesterday you took like 40 minutes to get the ice cream, so... Where are you getting your ice creams from? Are you going to the gas station to get ice creams? See you next time. Bye bye. Thank you for watching. Don't forget to subscribe and leave a like. So how am I going to solve this problem? This needs to happen when I already have a velocity, but I only have velocity after the first frame, because this will not happen before the end of the process. I say first frame, but it's not the first frame, because this is not one frame, it is more than that. So maybe I need to, if it's first frame, I need to count like, if it's not the first frame, no. If it's first frame, it doesn't do it. Basically, I need to check, I need to do this only in the second. And not only that, now the velocity delta needs to be calculated only after the first frame. And this needs to be set up on the second frame. I don't see any other solution for this, because I need to set up this in the second frame, because the first frame these numbers will not be compatible with the second frame when we have speed. But if we calculate the delta and we have a very weird number in the first frame, the ship will break. So we can only do this after the second frame. Or we do all of this in the ready function without this line. So when we get to the process, everything is already done. It could be. But if the polar gravity ready function happens before the other one, this will be sent this will be sent to okay, it could work. So this needs to happen. Where is the rigid body manager? This needs to happen calculating the forces. If the force is whatever, do whatever it needs to do. This needs to happen in the ready function, and then every frame. So what I'm going to do is to have another method that I can call in the ready, and on every calculation of the physics process with the things that I want to be repeated. And I will call this physics calculation, maybe physics calculation, and this needs to receive a delta. I don't know if I need a delta, but if I need, I cannot put a delta here, because in the ready function there's no delta. I don't use the delta anywhere, so okay, ignore the delta. If I need it, I will solve it later. So this physics calculation will have what? We'll have this, calculate the player plus the polar gravity forces. And if we send it some number to start, also there, paste. So this happens inside physics calculation. So this disappears. And first thing to do is physics calculations. After that calculation being done, we apply it to the rigid body. This could be also inside there, because we need to do this also in the ready function. So this goes to the end of it. Here. Save. The first frame, or before the first frame, that will be set up here. So physics calculation. We calculate everything, we applied the and we apply the forces to the body. So next frame, which is the first frame, we will do maybe this can also happen inside the other one. Bam bam, paste. And now we do that tricky thing. So this should already have a number, and this should be working properly because it's already prepared from before. Okay, let's do it. Let's see. Calculate the velocity difference here. So if it's the first frame, we make sure old and linear are the same. If it's not, we will ignore this, and then we have the delta, and then we set up the old every frame. Okay, let's play and see which numbers we have now. Play, continue, orbit, play. Okay, we have numbers now, it's not 0. Well, it's 0 is, come on. We still have the same problem. So setting up the rigid body in the ready function does not solve the problem. So when we reach here, the first frame, we will have 0. I guess I will ignore the first frame. I will ignore the breaking of the spaceship in the first frame, that there's no other option. There is no other option. I'm not seeing any other option. So let's go, instead of his first frame, let's call this frame count. Frame count on ready. Frame count equals 1. If the frame count equals equals now is lower, is higher than 1. We do this. No, I cannot do it this way because it will do this every frame. Is equal to 2. I will do this and then I will set up frame count equals 3. So it will happen only once. Now I need to set up the first frame. This is very ugly. I don't like this solution at all. If frame count equals 1, frame count equals 2. So this happens at the end of the frame. Whoop, whoop. Here. So we start at 1. At the end of the frame, we increase 1. Only if it's number 1. Yeah. We increase the frame count. So next frame, if frame count is 2, we will set up the collision whatever, and we say frame count 3. So we are in the third frame. And here, if frame count is higher than 2, we calculate the delta. So we only start calculating the delta when we pass 1 frame. We start at 1, the second is to do the calculation, and we only use the delta after that. This is not a very clean solution, but I'm not seeing any other at this point. Maybe I'm just too tired and tomorrow I look at this code and I say, oh, come on, please. But anyway, let's see if this solves the problem or if we are still with 0 linear velocity. Yeah, the delta should be 0, not the linear velocity. Okay, so let's play. Let's play. Play. Stop. Yes, we have something. Now we have something that is not 0. Okay, let's see. If the spaceship does not explode in the beginning. Okay, it's not exploding. Let's try to fall into that planet. Maybe this is too fast. Let's put it, the spaceship start slower. Start local velocity. I need to change this name. I don't like this name. Because it's not velocity, it's force. Let me change the name. Start. Local velocity, copy, paste. Substitute for start force. Local force. But the polar gravity doesn't have this variable. If it's not, it should. Substitute all. Start local force. Okay. Start local force. Okay. Okay. So let's build and start local force for the spaceship. Should be -100. I don't remember if it was negative. Yeah, minus because it's backwards. Okay. Continue. Let's see. Is this thing moving? Yes, it's moving super slow. Maybe I need to put a bigger number. Yes, it's happening. Okay. So maybe like quadruple that, 400. And in the other one, it was too fast. So rogue planet, we can go -600. Let's see if these speeds are more interesting. Play. Number 4. Needs to be faster, a little bit faster. And the thing breaks apart. Nice. Let's try the other one. Wrong direction. Ship. Well, should be 3,000. Play, continue. Orbital insertion. Okay, I like this speed. The planet is not moving fast enough. And the planet is not actually moving. Yes, it's moving super slow. Okay, let's put the planet going faster. Where is the planet? Yeah, of course it's not moving. It was moving because the spaceship also has polar gravity, so each object attracts to each other. But in this case, let's go to the right. Should be a positive number here. Like 60,000 maybe, and -5,000. It goes a little bit up and a lot to the right. Okay, more like it. I deaccelerate a lot. I will fall. No. Orbit. Stay in orbit. Okay, it's actually playable. I almost died there. I need to accelerate a little bit here. And brake now. Whoop. Accelerate here. Brake in the lower orbit. Accelerate in the higher orbit. And yeah, I have a circle more or less. Because the planet is moving, it's very difficult to keep perfectly circular, whatever. Let's collide with the planet and see if we have that behavior that I was expecting to have in the beginning, which is the debris is projected, but it stays in orbit. Oh, the level. Oh, okay. yeah, the level ended because I ended the fuel before I explode the ship. So let's go at least one orbit. Before crashing. Because what I want to do is to have the planet more in the center. Okay, points. This is very nice. Now the debris are in orbit. Space debris. The problem of humanity. And I changed the direction of the planet. It's no longer going up. This is beautiful. So I believe I have everything I need to build more levels. I'm pretty sure I have everything I need to build more levels. Let's remove all the prints. So find Godot print, substitute by / Godot print. I guess I can do whatever I want now. These bugs are related with the menu. Okay, that's a future problem. This is happening because when I play the last level, I cannot unlock the next level because it doesn't exist in the list, and I need to have a condition. If it's the last one, don't try to unlock the next one. But I didn't have that yet. Let's see if every level is still working, because I changed a lot in the physical part of the thing. So let's play everything, audio on, with music and everything. Project, general, full screen. Let's enjoy the game a little bit, see if everything's okay. And if everything works as I'm expecting, maybe we finish the stream after this experience. Or if I have something very simple to change, I will change it. But yeah, this is the last playing of the day. I will even start a new slot. Start game. It should be all. Oh, yeah, I will change this. No, I will not change this. I have an option in the save system that unlocks every level if the variable is true, because I want to test the levels without having to play all of them. Anyway, play.
Initiate forward thrust. Thrusters engaged. Decelerate using backwards thrust. Prepare to stabilize. Deceleration executed. Stabilizing. Start right lateral acceleration now. Thrusters engaged. Correct course. Decelerate thrusting left. Deceleration executed. Stabilizing. Rotate towards target using the thrusters and stabilize orientation.
Target alignment stable, holding now.
Prepare for brief main engine burst.
I'm not very aligned, but anyway, let's try.
Engaging main engine.
Rotate backwards towards the target.
Too much.
Deceleration complete.
Okay, level 4.
Prepare for main engine burn to decelerate as you approach the station.
Ready to start rotation. Engaging now, ready to maneuver into docking position.
I want to be stable
Use thrusters to align with dock 2.
first. Okay, 0. Nice. Spinning rate 0. It will be very simple.
Use thrusters to align with dock 2.
I know. There's no dock 2 here. Well, there is, but I don't go there.
Auto lock activated.
Roger that.
We are docked.
Roger that.
Station expansion.
We are docked.
Roger that.
I want to do something, but it could be so nice, but very, very difficult to implement.
Auto lock activated.
Roger that.
We are docked.
Roger that.
I don't remember how much is the limit speed for docking, but I guess I'm too fast. Stop. Let's not collide with the panels.
We are docked.
We are docked. Let's try to deaccelerate, because the station is moving. 0, 0. Okay. Let's go. Let's return to the parking position. This is the objective of this level. How much fuel? 96. Okay, so I did the level in 5 of fuel, more or less, because I started with 100.
Auto lock activated.
Roger that.
I'm rotating too fast. Whoop. Well, now that I'm thinking, I need to add more stuff here. I cannot lock if I'm rotating too fast, and I cannot I need to also brake while rotating.
Roger that.
Planet orbit insertion. I need to keep the speed low, but if it's too low I will crash. Oh, I didn't crash. I scraped the planet, but I didn't crash. I need to accelerate here or else I will. Just a tiny bit, okay. Brake now. Because the planet is moving, I cannot do a circular orbit. Yeah, it's kind of working. Eventually I will have to escape the planet to return to Earth. Right now, like, I will have a target here. I need to pass through the target at high speed to go home or whatever. I really like this level. Let's restart the level, because now I want to crash the spaceship. Now I want to crash the spaceship to see the debris orbiting the planet. This is amazing. Those big chunks went out, and I don't believe they will come back. Maybe they had too much. Oh no, they are coming. They are still inside the planet's gravity. No, I just want to enjoy gravitational whatever, so I will just add more time to see. End game area, let's do like 200 seconds. So let's just enjoy orbiting debris, and then we end the stream. Let's go. Let's kind of go against it, but less in the corner. Yeah, this is not sideways enough. Oh, crazy level. Not for me. Maybe a NASA astronaut would be able to finish the level. Let's put the space station orbiting the planet, and the mission is to dock to the station. The planet needs to be stopped, like, because it's very difficult to have a circular orbit. But that would be nice. Let's see if I can crush it into the other direction. not this time. Let's go. No, too fast. The things go away. They don't return. I need to have a button to speed up the game, the simulation. Because in this case I would like to see how far can we go. And I guess the big blocks don't return. Let's restart again. Well, they are super light. I guess they have 1 kilo. Maybe I can give them more weight, so I can impact faster to have this kind of simulation. This is amazing. Because technically all of them are attracting each other. So the calculations behind this is crazy. What happened if I put more spaceships? Let's duplicate the spaceship just to see what happens. Probably it will give us errors. Whoop, 2 spaceships. Play, continue, last one, play. Yeah, that one is not. they collide with each other. Oh, let's see what happens. Because the things will start to fall. Yeah, it will take a lot of time to fall. Okay, this cannot happen. Ship 2. Delete. Okay, I'm kind of happy with this. I don't like that last solution I did. The script is very ugly. But yeah, whatever. If it works, it works. I really don't care. At this point, I guess I don't care. How fast can I go around the planet? Small, lower orbits. I need to deaccelerate. This is very difficult. It gains speed when it starts to fall. Gains speed, so it gets. It's very difficult. Very interesting. I really like how difficult it is, because it's not extremely difficult. It just demands for the player to actually be all the time adjusting the speed. There's no autopilot here. Yeah, I really like that. Let's see if I can get really close to the planet. I need to deaccelerate. Because if I go too fast, I will be ejected very easily. Okay, I need to deaccelerate the lower orbit and accelerate in the. Okay, oh, I almost hit the planet. Do it faster. Stop. Come on. It's actually difficult to maintain a specific altitude. I will try just one thing more. I will stop the planet to see how much easier it is. So the planet is here. I want to disable that UI labels. Okay. The planet is here. It's a fixed planet. It doesn't move. So let's freeze the planet. And this will be extremely easy compared to the moving planet. Extremely easy. I'm pretty sure. I will get the perfect circle here. Let's start the accelerating right now. Low. Let's do it again. Right now. Okay. Let's keep the altitude. So the accelerate on the lower orbit, which is around here. Yeah, much easier. Come on, this is almost a circle. So now the lower orbit is on this side. Let's go all around, tiny bursts, to make sure we can actually descend evenly all around the planet. Yep. Oh, no, not this side. I'm almost in a perfect circle. Yep. I'm getting higher. Why? It's much easier if the planet doesn't move. Whoa. Stop here. Whoa. Okay. Okay, last fuel will be to crush. No more fuel. Yeah, I'm really liking it. So I don't know what I'm going to do tomorrow. Maybe tomorrow tomorrow afternoon I will look at the project and take some notes, and I will decide tomorrow afternoon what I'm going to do tomorrow at the stream. Today I wanted to try something that but I didn't have the opportunity, which was to model the spaceship. If you look here, let's go like level 3, for example.
Rotate towards target using the thrusters and stabilize orientation.
If you look at the spaceship, you have a shadow here and a light in this side, and this you see these steps into the shading. This is because the UV mapping was made like I painted by hand just to test if the thing worked, and this is the only object that has the shading. But I would like to have a smooth transition, not this steppy look, because this is round, it's not octagonous or whatever. So what I want to do is to model the thing in Blender, just to have the normal map. It's not normal map, it's the UV map. UV map, where is the sprite? Yeah, this is the UV map. For those who don't know what this is, the color of the UV map represents the direction of the light, or the direction of the surface. So if the light comes from the right, the pink part will get illuminated and the blue part will get shadow. So no physics process needed. It's just give light to this color, give shadow to the other color. It's a 2D thing. But yeah, I painted this by hand. That's why it's ugly, and it has the reference up there. So what I'm going to do tomorrow, maybe in the afternoon, is to model the thing in Blender 3D, just to get the smooth shape of this normal map. And yeah, if it works as I'm thinking it will work, I can even add more detail, like the door being a little bit pop, have some thickness, and this grid could be a little bit better, and that one also. So, and the engine could have the all these ripples have a 3D appearance. But yeah, this is a painted asset, like in real paper. So I don't want to lose that, so I'm just adding this this normal map just for the shading, because I like the paper texture and whatever. So maybe that's what I'm going to do tomorrow afternoon, and then at the stream, I don't know, maybe I implement this here, or I show what I did, and I don't know. We will see. Another thing I want to do, because we can pilot the spaceship into the station, but I also want to command that harm that the station has. Where is the space station? So this arm at this point is just a fixed thing, but I want to control this arm. So 1, 2, 3 controls. So it's the opposite. We are no longer piloting the ship, but the ship is in autopilot. It reaches the point and it stops at the right position, and then we need to capture the thing and dock it by operating this arm. It could be an interesting, different way of playing the game. I also want to implement landing. I have a landing. I have a landing mission in the Unity version that was working. So maybe I can also do that here. Well, I don't know. Thank you for watching. Please subscribe and like the video if you are actually interested in this. And see you in the future. Bye bye.